So we can just start. Like I said last week, I hope that those who are not able to make it view the lectures that I post on YouTube. And so that is going to be very helpful. Sometimes the lectures are posted on YouTube, and you can also see them in the file folders for each week. I don't think that the file folder for this week was posted. I mean, the lectures for this week, or this second module, was posted from last semester. So I'm going to record this one and I'll post it. But please, when I see nobody take it that, excuse me, there are no problems. And so I will not post any lectures. In any event, I hope we're all paying attention. So like I said last week, this course is going to assume, first of all, that you had the first statistics class and that you know about descriptive statistics already, and you also have knowledge and understanding of how to use the normal probability distribution. So we will not go into any review of normal probability distribution in depth. Nor are we going to go back and try to describe it, but I'll provide some examples of normal probability distribution and how we are going to apply it going forward. So this class is going to be focused on inferential statistics. And so in order to do inferential statistics, you have to have an understanding of the kind of probability distribution that you are using. So, or you are applying. So I'm going to proceed immediately to talk about the topic for this week, which is going to get into mostly confidence interval estimation, because confidence interval estimation is the beginning of inferential statistics. That is the foundation for inferential statistics. And everything else is an extension of confidence interval estimation. So I'm going to pull up, I'm going to share some slides, and I'm going to use those slides to explain things. And so please pay attention and I'm going to do some examples. I would also proceed to illustrate, using an example of like your homework assignment, something like that. So at least you have an idea where we are going. So let's begin. I'm going to share screen. All right. So this is what we're going to be referring to. Prepared few PowerPoint slides for this class. Our emphasis today will be on confidence interval estimation. Okay. But before we go into confidence interval estimation, are you able to see my screen? Hello? Are you able to see my screen?
No. Oh, I see a picture of you.
Okay, I'm going to share screen again.
Okay.
You can see my screen?
Oh, yes.
All right. Are you still able to see my screen?
Yes.
Okay. All right. So today we're going to talk about confidence interval estimation. And confidence interval estimation, as I said earlier, is the beginning of inferential statistics. Okay. So let's, as I said, we go from confidence interval estimation and then we go to hypothesis testing. All right. So what is it that we do in confidence interval estimation? As I said last week, in order to do statistical analysis, first of all, you have to define a problem. Okay, what is your problem? You have to define that problem, and then you ask yourself, when you set up the formulas, then what is your objective? Okay, so what is the problem? Now, in confidence interval estimation, the problem, like I said, in inferential statistics, you use information from a sample in order to reach conclusions or make judgments or inferences about a population. We use samples in statistics because getting information about population is problematic for a number of reasons. One of which is that it is actually difficult conceptually to define strictly what a population is. For example, if you are thinking about a fish pond, okay? Now, think about a fish pond and you want to ask yourself, what is the average size of fish? What is the average weight of fish in that fish pond? Okay. And if the fish pond is open, for example, fish come in and go, and so you cannot exactly say what the population, what the average, the exact average of fish in that fish pond is. Okay. But you can think about, whether the fish that come here have a certain characteristic. For example, they are of a certain average weight. You go to a poultry, for example, you ask yourself, what is the average weight of the eggs that are laid in that poultry? At any time, you cannot say exactly what the population is. I mean, that's number one. But if you can, trying to get information about the population is going to be time consuming, all right? Suppose you ask yourself, what is average travel time of students that come to school at Medgar Evers College? You cannot exactly get the population of students that come to school on a particular day, let alone over time. Because if you want to know the exact number of students that come to school on a particular day, then you have to get a roster of all the students that are registered at the college, and then pick up your phone and ask, did you come to school today? And how are you sure you're going to get information from everybody? Some will not pick up the phone, and even if everybody picked up the phone, it will take a long time and it will be very costly. But information from a sample that reflects the population is sufficient for us to be able to make inferences about the population. And so what is it that at this level of analysis, what is our objective? Our problem is that we want to know the average of, say, travel time of students that come to school on a particular day, okay? And so that average, you're looking for the population average, the exact population average. For example, what is the average amount of money that a customer spends at a lunch? How do you know? First of all, what is the population? It's impossible to define the population here. But that population will have a characteristic, okay, which is, say, an average amount. For example, if you're looking at Medgar Evers College, you're going to be asking, what is the average amount that a student spends at lunch? Now, it will have a characteristics. Now, remember, these are students. They are not like high-income people. You cannot compare them, for example, to the average amount that a United Nations diplomat spends on lunch, because they are not of the same characteristic, okay? Nevertheless, there's a range of values, okay? Now, so our problem then is what? Our problem is that we do not know the true population mean. The true population mean comes from knowing the exact number of members of that population. And so if you can get information from every single member of the population and you calculate that average, then you get the true population average. But if you don't have information from every single member of the population and you are taking only a sample, then you do not know exactly what the true population mean is. But you want to be able to estimate that population mean using a sample. The population mean is mu. As you can see from the slide, the population mean is mu, which you see there is symbolized by the Greek letter mu. Now, we want to estimate the population mean using the sample mean X bar. And the way you use the sample mean X bar is to use X bar combined with the distribution of the true population mean with a Z value to estimate a confidence interval. Okay? And so in summary, in inferential statistics, we use X bar to estimate mu, which is the true population. And you also estimate other kinds of characteristics. You use S to estimate the true standard deviation. You can use S squared to estimate the true variance. And you can use rho, which is the population proportion, to estimate pi, which is the true population proportion. Now, the true population proportion, for example, will be what percentage of students or what percentage of kids like to eat their vegetables. Okay?
Professor.
Yes.
We're not seeing the slide. We're seeing your resume.
Oh, you're not seeing the slide? You see my resume?
Yes.
But
impressive.
all along, somebody said you were seeing the slide.
I don't know who said that. I'm looking at your resume for 72 Jewett Avenue, Staten Island.
Yeah, I'm giving away.
Yeah,
All the information.
you asked if we was able to see the board. We could see the board. I wasn't really sure what you was trying to show us. But yeah, it's the resume. I apologize.
Okay.
It's impressive, Doctor. I'm joking.
Okay, let's see what's going on here. I will stop share again.
You might want to remove the recording also.
I'm not gonna remove it, but